All right, so we were working on rational equations, solving rational equations, and a lot of you wanted to see some examples of that. So um, here's one example. I'll do kind of one easier one and then one that's a little bit harder. And the reason I have Desmos up is because I just want to remind you that we can always check our answers by using the graphs, seeing where the graphs intersect. So my idea whenever I'm doing a rational equation is let's make a common denominator and then let's get rid of all the fractions. Luckily here, 2 and 3 both go into 6. And so what I'm going to do is just take this term times 2, this term times 3. So that leaves me with 2a minus 3 over 6 equals 4a over 6 plus 3 over 6. What I'm going to do next is multiply by 6. And what I hope you notice is 6 divided by 6 is 1. And if you distribute the 6 here, you're going to see 6 divided by 6 and 6 divided by 6. When you get a common denominator, you are just one step away from having no more fractions. Because if you have a common denominator, the only way that the left side is going to equal the right side is if the numerators are the same. You already made the denominators the same, so really you just need to make the numerators the same now. And so then I just have to get my letters on one side. So negative 3 equals 2a plus 3. Subtract 3 from both sides. So negative 6 is 2a. And divide by 2. So negative 3 is a. So let's see if that matches up with what I get when I type in the equations. So I'm going to type in, I'll use the letter x for my graphing software, 2x minus 3 all over 6 versus 2x. Oh, it all moved around on me. Okay, 2x over 3 plus 1/2. And you can see that they do cross over at one point. Let's try to get that a little clearer. They do cross over here at one point when x is equal to negative 3. Okay? If you checked your work and plugged in negative 3 for x, both sides of the equation would equal negative 1.5. So there's one example. Let's do one that looks a little bit harder. Let's look at this one here. We can do x plus 9 over x squared minus 4x minus 3 over x equals 1 over x minus 4. So we want to make a common denominator. On the earlier one, I could just see that 2 times 3 made 6. Here, we have a very similar situation. You can see that x times x minus 4 makes x squared minus 4x. So I'm going to multiply this middle term by x minus 4 and multiply this end term times x. So now I have x plus 9 minus 3 times x minus 4 equals 1 times x, or just x. And you might think, wait, where did those denominators go? Well, once I have common denominators, I can multiply by x minus 4, and it cancels out all the denominators. So again, if two sides have common denominators, if two sides of an equation have common denominators, then to solve them, you need to make their numerators equal as well. So then if I distribute that out, I have x plus 9 minus 3x plus 12 because of two negatives equals x. Combine some like terms. So I have negative 2x plus 21 equals x. Add 2x to both sides. So 21 is 3x. And divide by 3. So 7 is x. Check our answers on this one here. So we've got x. I don't know why the text is jumping around like that. That's really annoying. So x plus 9 divided by x squared minus 4x. You should also know why the graph looks like that. Minus 3 over x. Okay. And then on the other side, we have 1 over x minus 4. And we can see that they only cross over one time where x is equal to 7. So indeed, it works out. This video is not too long, so maybe let's just do one more example here real quick. So, let's do one more example. And I won't graph to solve this one. Let's just say we had 2b minus 5 over b minus 2. And then minus 2 equals 3 over b plus 2. Let's make a common denominator. Right now, 2 has a denominator of 1. So I'm going to multiply this term, this first term right here, has a denominator of b minus 2. So I'm going to multiply it by b plus 2 over b plus 2. I'm going to multiply this term on the end by b minus 2 over b minus 2. And the middle term is going to get multiplied by both on the top and on the bottom. Then I can just clear out all the denominators from the problem, the same reason I've discussed. So now I have b plus 2 times 2b minus 5 minus 2 times both of the pieces. And then all right, so we had all of that, and then here, get out of the way. Let me do this. Sorry, I got menus all over the place. Okay, so then here we got rid of the denominator, so we just have 3 times b minus 2. Okay, there's going to be a lot of just distributing out. So I'm going to do it quick, and just let me know if something was trippy and you got messed up. So 2b squared plus 4b minus 5b minus 10. Then here we got minus 2b plus 4, b minus 2, 3b minus 6. This simplifies a little bit. This one I can distribute again. 2b squared minus 4b plus 4b. I guess I could have factored that a little better, but that's okay. I'm just trying to go quick here. Then what's nice is 2b squared minus 2b squared is 0. 4b minus 4b is 0. So a lot of stuff cancels out, and I've really just got negative b minus 10 double negative 8. And then over here I've got 3b minus 6. Okay. So we can make that negative b minus 2 and 3b minus 6. We can add 6 over here to get negative b plus 4 is 3b. Add b to both sides. Get 4 equals 4b. So b is equal to 1 if you just divide both sides. So if you have b equals 1, you can check your answer in the original problem. You'll see you get negative 3 over 1 minus negative 3 over negative 1 there. Yeah, equals 3 over 3 there. Okay, that looks good to me. All right, so please let me know if you have any questions. Thanks for watching.